Okay, section 1.1 part 3 wraps up the recordings for section 1.1. We're on example 6. It says a furniture store offers free setup and delivery to all points within a 25-mile radius. In 25 miles, they'll deliver and set up free of the warehouse distribution center. If you live 20 miles east and 14 miles south, of the warehouse, will you incur a delivery charge? And then you have to justify your answer. Well, in order to, again, make sense of this, we know that we're going to put the warehouse distribution center, so W for warehouse, right smack at the origin. Now, we're 20 miles east. Let's let this be east. So we're 20 miles east and 14 miles south. So I'm going to let this be south. So I'm over here. So we're at the point 20, comma, negative 14. And all they're asking us is whether or not that distance between our house and the warehouse is less than or equal to the 25 miles. And that's what we need to determine. So let's come in and find the actual distance using our distance formula again. So that distance formula, as a reminder, is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So I'm going to take my 20 minus 0 and square it. And then we'll take our negative 14 minus 0 and square it. So 20 minus 0 just gives me a 20, which we're going to square. And the negative 14, which we're going to square. So 20 squared is 400. And 14 squared is 196. And if we add those together, we get 596. Now, because this is an application problem, we're just going to go ahead and take the square root of that on our calculator. So second square root 596 gives us 24.4. And that is an approximation, 20.4 miles. So we're saying that our house is 24.4 miles from the distribution center. So yes, we get free setup and delivery. So to answer the question, yes. Free delivery, which is always a good thing. So trying to give you a practical application of why you would need the distance formula to determine whether or not you get free delivery, if you're close enough. Example 7. So example 7 says, find the coordinates of the points that are 5 units from the origin and having an x coordinate equal to 3. So again, example 7. Find the coordinates of the points that are 5 units from the origin, and their x coordinate is equal to 3. So 3 comma y, because we don't know the y coordinate. So to get a handle on what they're asking us is, we know we're over here at 3 something and starting from the origin. And I'm going to go in this direction just because it's easier to think about it in terms of a positive. But we know that this is 3 comma y. This point is 0 comma 0. They're telling me that that distance is 5. So we just need to come in and solve this for y. Using the distance formula yet again, using the point 3 comma y and 0 comma 0. So our distance this time is 5, and that's going to be equal to x2, which is 3, minus x1 of 0, plus y2, which is just y. I don't know what it is. That's what we're going to solve for. Minus y1, which is 0. And now we just need to algebraically solve it. So 5 is equal to the square root of 3 squared is 9. The y minus 0 is just going to give me a y squared. To solve this for y, the first thing we'll do is square both sides. That eliminates that square root. So we're going to come in and do 5 squared equals that square root squared. 5 squared is 25. On the right side, the root and the square disappear. You're just left with the 9 plus y. Solving for y, our next step is going to be to move that 9. That'll give us y squared is equal to 25 minus 9 is 16, which comes out really nicely as an answer. Finally, your last step is to square root both sides, and y equals plus 4 minus 4. Wait a minute, do I really have 2 answers? Well, yeah, you do. You have one of them up here at 3 comma positive 4. And then there's another point that's the same distance away on the negative side of the axis. So 3 comma negative 4. So our answers, to make sure you're understanding our 2 answers, One of the answers is 3, 4. The other answer is 3, -4. And those are all the points that have a coordinate equal to 3 of the x, I'm sorry, x coordinate equal to 3 that are 5 units away from the origin. One more example, and then you're ready to tackle the homework in section 1.1. Final example, this is 8. It says a grand tour begins of 4 cities, begins at city A, and city A is right here, and makes successive stops at city B. B is over here and actually labels the points for us, so it's 400, 300. City C, which is over here, and again, my drawing is not to scale. It's at -800, 800. And finally, city D, this is D, and it is a 800, -800, 0. Sorry, little squish. Good thing you have the hand up to look at. We want to find the total distance covered on the tour. So if we go from A to B to C and then back to D, how much have we covered in terms of total mileage? So what we need is the distance between every pair of cities to give us that. So let's come in and find the distance, and I'm going to use a little AB to indicate I'm finding the distance from A to B. So we'll take our x2 minus our x1. Again, remember that's the origin. So that would be 400 minus 0 squared plus 300. That's y2 minus y1 squared. So that's 400 squared plus 300 squared. It's going to give me 400 squared is 16 with 4 zeros, 660,000. 300 squared is 90,000, so 4 zeros, which gives us altogether 250,000. And when I square root it, I should get 500. So the distance between A and B is 500. I'm going to write that in over here just so I can keep track of stuff because my board's not big enough. So there's 500 miles sitting right there. Okay, now we're going to go find the distance from B to C. So I'm going to indicate that with a little subscript of B and C. Okay, so this time we have -800 minus 400, which we're going to square as a quantity. Then the change in the y is going to be 800 minus 300. So -800 minus 400 is a -1200, which we're going to square. 800 minus 300 is 500, which we're going to have to square. So we've got some really large numbers here, but they're fairly nice numbers. So when I take that -1200 and square it, I'm going to get 144. That's the 12 squared. And then I'm squaring the zeros, so I'm tacking on 4 zeros. 5 squared is 25, and again, I'll tack on 4 zeros. That's the squaring of the hundreds going on. So if I add that all together, wow, I have 1, and then the 2 and 5 are going to add here. That's going to be 169 with the 4 zeros. So that's really what, 1,690,000, but we're going to square root it. So that works a lot better in our favor. And the square root of 169 is 13, and I'll tack on the 2 zeros for the square rooting. So again, you're going to use your calculator, which is fine. These are numbers that are fairly straightforward for us. So this side of our tour is 1,300 miles. And before I go too much further, let's recognize that this distance that's going from city C to city D is really just a vertical drop down. So I can use the distance formula, but I don't need to use the distance formula. I know my y coordinate is 800 here and my y coordinate is 0 here. I haven't changed in the x direction. So this thing would be 0. All we're doing is doing the 800, squaring it and square rooting it. So we can see that the distance from, I knew I was going to run out of room. The distance from D to C is simply the 800 miles. So that side of our shape is 800. And then finally, what about the bottom part of this from D to A? So the distance from D to A. So this time we're not changing the y coordinate, only in the x coordinate. So again, if you use the distance formula, this time this part of it would be 0. And over here you would have 800 squared and then square root it. So it's going to come out to be 800 also. So now we have all 4 sides of this what, quadrilateral? A four-sided shape is a quadrilateral, and we just need to add them together. So we're going to add our 500, our 1300, our 800, and our 800 all together. So we're going to have what, 18 plus 16? That was good. So 13 plus 5 plus 8 plus 8. So all together we get 3,400 miles. So if you travel between these cities using a straight line distance, the total distance is 3,400 miles. You'll see one very similar to it on the homework. That wraps up section 1.1. Good luck on the homework, and we'll see you in section 1.2.